Okay. So that, like I said in the previous video, that is like the basic, most straightforward U substitution. Here is one that, believe it or not, can be done using U substitution. First of all, let's just, with what you know right now, let's just see, hey, does any part of this function have its derivative elsewhere in the function? And hopefully you're coming up with a no, because check it out. This bottom here, if I take its derivative, do you agree I get 3x squared plus 6x? And is that anywhere else in the function? I don't see it. But is it pretty close to what's on the top of the function there? In fact, is it only different by a factor of 3? So if you're only off by a coefficient like that, you can still do U substitution. It'll totally work. So that's why I want to show you here, okay? So let's just do U equals, and that'll be this whole bottom part. Okay, and then du, I'm going to skip a step here just because I think I might run out of room otherwise. Dx, right? Now, if you can just think ahead a couple of moves, you'll see that we're going to run into like a hassle. Because when I go to rewrite this integral, I'll have the integral sign. I'll just actually write it. On the bottom, that big mess, what does it simplify to? Just u to the 4th, right? And then we have this thing here that we still have not represented down in this integral, but we're out of luck because we don't have anything that matches that exactly. But can you make it match exactly? Totally. Watch this. This du here, I'm just going to multiply both sides by 1/3. So this is 1/3 du then. And if I multiply this by 1/3, guess what that 3x squared becomes? Just an x squared. And guess what this 6x becomes? 2x. You see what I just did there? I just got rid of that coefficient that was lousing us up by multiplying on both sides to get rid of it. And now, like, at this point, it's just kind of like the same that we were doing. I'm just going to rewrite this now. Integral sign, integral sign. I'm going to have u to the 4th on the bottom. And guess what I'm going to have on top? Well, this is, I still use my red marker. I've got this thing here. And this thing here is not represented. So, I can tell, though, that that's equals 1/3 du. Now, you haven't done enough integrals probably for that to, like, make you feel that happy, because that can look kind of disgusting at first when you're still new. But here's the thing. Can you kick out a coefficient, and can you collapse fractions? You totally can. So guess what I'm going to do with that 1/3? Scoot it out. And guess what I'm going to do to this fraction? I'm going to collapse it. This is the same as this, but I have a way better shot at integrating that guy than I do with the one above it, the line above it. So just remember, when you integrate, when you're going up the ladder, you have to add 1. So let's just ignore this 1/3 for now, okay? So where can I write? I can still write over here. You can see it, right? Yeah. So I'll go over to here. So we'll have that 1/3 out front. I'm not doing anything with that yet. This will become u to the -3. And guess what goes out front there to take care of any coefficients? The reciprocal of this. So that'd be -1/3 plus c. And then you can always take the derivative to make sure you get back to that. And I think we do. And then this is just -1/9, I guess, if I multiply those together. U to the -3 plus c. But don't leave it like that, right? You always want to put it back into terms of the x's. So we're going to have -1/9, and then u is this mess. And if I, plus c. And if I really wanted to, like this might be the answer on the multiple choice, probably they would do something like this. Okay. So could you have just figured that out without u substitution? Yeah, I don't know if I could have. Like, there's those constants mess me up. But here's the thing. I should say those coefficients. Those coefficients, if you're within a coefficient, if your derivative is there, but it's just within a coefficient, easy peasy. Just multiply the du by whatever you need to get rid of that coefficient so that you have an exact match. Okay? I kind of feel like I don't know. You know, I'm just going to do the third flavor of this, okay? And the third flavor is, we have just been doing indefinite integrals. They're not area, they're just antiderivatives, all right? But you can do this with definite integrals also. You know, the ones where the caterpillar's crawling has numbers for the limits. So, let's do that. 0 to 2, x squared, x cubed plus 1 dx. Grody to the max to try to figure that one out without u substitution, but do you see something that has its derivative elsewhere in the function? Hopefully you just said no, but is it within a coefficient? Hopefully you just said yes, because if you take the derivative under that square root sign, you get 3x squared, and that's really close to x squared. It's only within a coefficient, so we can make that work. So, I'm going to do that. I'm going to have u be this whole thing here, and then du equals 3x squared dx, if I skip a step there. But I don't need 3x squared, I just need x squared. So I'll multiply by, it's not always you're multiplying by 1/3, that's just with the two problems I chose. Okay. And then everything, except for one thing, proceeds just like the rest of the problems. Let's rewrite the integral. I'll have the square root of u. And then the only thing that I haven't represented, well, one of the only things, is this and this. But guess what? They just equal 1/3 du, right? So I'm going to put the 1/3 out front and put the du here. And then you have the limits. So the thing you just got to think about with the limits is this. Up on top, at this top line here, we were dealing with x's, right? Caterpillar's crawling along the x-axis. If we're going to do everything in terms of u, that's fine. But you just got to remap those, or not remap, you got to map those limits onto the u stuff that we're doing. And it's easy, because you actually show the relationship. This right here tells you how u and x are related. So when x is 0, guess what u has to be? Well, just do 0 cubed plus 1, and I get 1. So that will be my new limit. And when x is 2, what does that make u be? 2 cubed plus 1, I'm getting 9. Okay? And then everything else is basically the same, except that we're just going to be doing a little FTC action, okay? Which I'll do, so because I know you're not super experienced with it yet. So if 1/3, 1 to 9, whenever I do calculus, I turn everything into exponential notation. And then when I find the antideriv, I add 1, that'll be u to the 3/2, and then I put the reciprocal out front. And I do not need a plus c, because I'm actually going to be doing this. Okay? I can simplify this a little bit, so it's just 2/9. You know, for you guys, yeah. I know, you know what I'm going to do here? I'm going to, let's see. Hopefully this isn't too much. That's u to the 1/2 is square root of u, and then cubed. I just think it'll be easier for you to see what I'm about to do if I do that. And then I just plug in the top. Oopsie, what the heck happened to my computer? Oh my gosh, 10 minutes. Okay, I plug in the top minus I plug in the bottom, okay? So, let's see if we can't just do this. 2/9. If I put a 9 in here, what's the square root of 9? It's 3. Now what's 3 to the third power? 27, right? Minus 2/9. And then put the 1 in there, and the square root of 1 is 1. Cubed is just 1. Okay? So I think this 9, and that becomes a 3. I think you just have 6 here, minus 2/9. 54, what is that, 52/9? Is that possible? Did I write the right answer? Oh, I did. Yeah, okay, that is it. All right? So those are the other two things that you can do with u substitution. Sometimes you have to multiply the du to get rid of an extraneous coefficient. And if you do the definite integrals, turn the limits into the u. Map them into the u by using whatever your u was, okay? Well, I hope that works. Thanks.